Hello everyone. In this lecture I shall discuss the electric circuits. Basically, since we are concentrating on first order differential equations, here I will discuss the RL circuit and RC circuit. Okay. So now a simple electric circuit consists of the following elements. One is the charge. So these elements are connected in series with a key or a switch. Okay. Coming to the charge, what do you mean by charge? It is the quantity of electricity. So in symbol we write it Q and the unit is coulomb. Okay. Then coming to the second, current. Current means the rate of flow of the electricity, and in symbol we write it I and the unit is ampere. And if we want to connect this Q and I, here I is equal to dq by dt. I is equal to dq by dt, or here q is equal to integration of I dt. So in that way we can connect I and q. Now coming to the resistance. So the symbol is R ohm. If we understand it symbolically, the resistance in a circuit it is like this. Okay, this is your resistance, right? This is resistance here, R ohm. And inductance here is denoted by L. The unit is Henry. And in a circuit, if we want to see the symbol, so it is like this, right? It is your inductance in Henry. And in the capacitance, is C farad. Okay, so it is denoted like this, two parallel lines. Okay, two parallel lines. It is the capacitance C farad. Okay, and we have a battery supplying EMF. EMF means electromotive force. So the battery, the supplying EMF or supplying voltage or potential, and we can denote it like this, negative and positive. You mark this. Okay, these are two equal parallel lines, and here one is smaller and other one is larger. It is negative and it is here positive, and the flow is like this. Okay, and it is a battery source. If it is a generator source, we write like this. If it is a generator source, we write like this. Okay, we write like this. So here in battery source, E is treated as a constant. And in generator source, E is treated as a variable. Okay, E is treated as a variable. Similarly, here if it is negative and here if it is positive, and we can understand the flow like this. Okay, then coming to the key or the switch. It is like this. So when the key is open, right, when the key is open, there is no electricity, means the flow of electricity is 0 if the key is open. So I0 is equal to 0. It can be treated as an initial condition. Okay, it can be treated as an initial condition. So we may have a variable source, or we may have a constant source. Okay, and accordingly we will discuss the RL and RC circuit. So before the details of the discussion, let me to introduce myself. Professor S.K. Paikray, Kumar Paikray, currently is working as a professor in the Department of Mathematics at Veer Surendra University of Technology, VSSUT, Burla, Sambalpur, Odisha, India. Okay, so without much delay, let us now discuss the basic relations among these following elements, along these above mentioned elements. As I have mentioned, from the basic principle of electricity, I have already told the relation between I and Q. I have already told earlier. Now the voltage drop across the resistance R. Okay, so this is your resistance R here. So R here, what is the voltage drop across R? This is L, this is your C, right? This is your E. So now the voltage drop across your resistance R, it is your Ri, right? And the voltage drop across your inductance L is L di by dt, okay. Then your voltage drop across C, it is Q by C, Q is your integral I dt, so 1 by C integral I dt, okay. So now we will discuss the Kirchhoff's law. So we have two Kirchhoff's law, one is Kirchhoff's voltage law and another one is Kirchhoff's current law. So we will discuss in details, okay, KVL and KCL, and our differential equation solving RL and RC circuit or RLC circuit, these are all depends upon the Kirchhoff's voltage law. So let me to write this law as follows. So coming to one, Kirchhoff's voltage law, KVL, okay, voltage law, Kirchhoff's voltage law. So what is that? The algebraic sum of potential drop, the algebraic sum of voltage drops or potential drops across a closed circuit is equal to the resultant EMF. Resultant EMF. That means suppose you have a circuit like this. Suppose you have a RL circuit. This is the source and we have a RL circuit. Then here voltage drop across R. This is my R, this is my L, and this is my E0. Say E is equal to E0 plus voltage drop across L is equal to E0. This E may be E0 constant or some variable. If I write it E0 sin omega t, then it is your variable fluctuating, right? It is constant. So anyway, whatever it given. So the algebraic sum of voltage drop across a closed circuit is equal to the resultant EMF. So this is basically I have written an RL circuit, and accordingly we will frame a differential equation subsequently. Now coming to the Kirchhoff's current law, KCL, Kirchhoff's current law, the algebraic sum of current meeting at a junction, the algebraic sum of current meeting at a node is 0. What does it mean? Yes, sum of the incoming current is equal to sum of the outgoing current at a junction or a node, okay. So this is what your KVL and KCL. Now let us discuss the RL circuit, okay. RL circuit, as I have told you, the RL circuit consisting of R, resistance, inductance, source and a key. So as we discussed earlier, the RL circuits consist of your R, resistance and your inductance, and you have a source and you have a key, say right? We have a key, say. So this is R, resistance in ohm, and inductance in Henry, and you have a source E here, and you have a key here, K. Now according to the KVL, according to Kirchhoff's voltage law, voltage drop across R plus voltage drop across L is equal to your E, right? Or suppose I take it E is E0, say. Here suppose I say my E0 say, okay, is E0. So this implies voltage drop at R is Ri plus voltage drop across L is L di by dt is equal to your E0. Now when the key is open, note that I of 0 is equal to 0. That means when key is open, no electricity in the circuit, right? So this is I of 0 is equal to 0. Now if you solve it, divide L. So that means if you divide L, di by dt plus R by L I is E0 by L. You note that this is a linear differential equation of order 1, okay, of order 1. So now you have, this is P, this is Q, say. You say this is your P, this is your Q. You know the integrating factor. So what is the general form of a ordinary linear differential equation? Y dash plus pxy is qx. Integrating factor is e to the power integral p dx. Then y into integrating factor is integral q into integrating factor dx plus c. So this is the idea. So we impose this idea here. So what is my integrating factor? So integrating factor is e to the power integral r by l dt. Okay. So this is equal to e to the power r by l t. So now the general solution. Thus the general solution is, let it be my equation 1. General solution of 1 is here I into integrating factor, I into e to the power r by l t is integral q, means E0 by L is a constant here. E0 by L into e to the power r by L t dt plus some constant C1. Now if you integrate it, E0 by L is your constant. E to the power x, integral is e to the power x, and this constant will be divided. Okay, so reverse multiplied into L by R. Integration is e to the power r by L t. So there is a constant, and we have a constant C1, added it to give C. Okay. Now bringing this to right hand side. So L here cancel here. So that means here I is equal to E0 by L, and this is cancelled, e to the power r by L t plus C e to the power minus r by L t. So this is the solution here. Okay. Now this C is arbitrary constant, okay, but that C earlier is a capacitance. Don't be confused here. So now we impose the condition I of 0 is equal to your I0. That means when t is equal to 0, I is equal to I0. So that means this 2 follows. Equation 2 follows. Here I0 is equal to E0 by L plus C into e to the power 0, means 1. So that means, so 1 second here, the initial condition is I0 is equal to 0 here. Okay. I of 0 is equal to 0 here is the initial condition. Initially there is no current. Here the initial condition is I0 is equal to 0. Okay. So we have this condition is I0 is equal to 0. So your 0 is equal to this. So that means your C is equal to minus E0 by L. Now we substitute this C here. So therefore here I is equal to E0 by L plus E, this is C is minus E0 by L e to the power minus R by L t. So this is equal to E0 by L taken common. This is 1 minus e to the power minus R by L t. So therefore E is equal to this, which is the solution of the RL circuit. Okay, which is the solution of the differential equation generated by the RL circuit with initial condition I0 is equal to 0. Okay, so we may directly write it if a short question. If it is a long question, then we should write the details. Similarly, for your RC circuit, you have your R resistance and we have your capacitance C. Okay, then RC circuit, and we have a battery and we have a key. Let this battery, this is the battery EMF, and we have a key. There may be a key or may not, but so there is a key. So this is a RC circuit. This is R, this is C, parallel line, same length. This is your C farad. Okay, and this is my battery E. You say it is E0, and this is my key K. Okay, so according to KVL, Kirchhoff's voltage law, here Ri plus voltage drop across C is Q by C. Q by C is EMF. EMF is here E0. Okay, so this implies if I solve it, it is Ri plus 1 by C integral I dt is equal to E0. Now if we differentiate it with respect to t, in order to avoid this integral sign, so this implies my R di by dt plus it is here I by C, and it is here 0. Okay, now if we divide this R, so that means R, this means di by dt, okay, is equal to minus of I by RC. Then you may use, we solve it by variable separation. Now if we want to keep it in terms of Q only, okay, so this is one aspect of solving. In terms of Q. So this is in terms of R, in terms of I. Now if you want to solve it in terms of your Q, let it be my equation 1. Solving case B. Solving in terms of Q, right? Solving in terms of Q. So Ri plus 1 by C Q is equal to your E0. So I is equal to dq by dt. So that means R dq by dt plus 1 by CQ is E0, since here I is equal to dq by dt, and here Q is equal to, since Q is equal to integral I dt. We have used this. Okay, so now, so that means here dq by dt, and you divide this plus 1 by RC Q is E0. So this is a linear differential equation. You see, this is a linear differential equation. So this is my P and this is my Q. Okay, so as usual we find the integrating factor e to the power integral P dx. then P dt, and here I into integrating factor is equal to integral here Q into integrating factor dt plus C. So this is what. Okay. So now coming to some examples. So here if you want to write one line, according to KVL, voltage drop across R plus voltage drop across C is equal to EMF, and subsequently we did it. Now coming to an example. An inductance 2 Henry, a resistance 20 ohm are connected in series with an EMF 100 volt. If the initial current is 0, find the current at the end of 2 seconds. Means it is a RL circuit. Okay. So we coming to the solution, draw the RL circuit. So this is your R and this is your L. Okay, and we have a battery. Okay. So here it is given E is equal to 100 volt and it is here 20 L is 2 Henry and it is 20 ohm. According to KVL, according to Kirchhoff's voltage law, voltage potential drop at R plus potential drop at L is EMF. So this implies potential drop at R is Ri plus L di by dt is here EMF is E here. We may directly write it. We may in RL circuit we may directly write it, or it is better we should solve it. Okay, it is better we should solve it if it is a long question. And then we have you divide your L, so that means di by dt plus R by L I is equal to E0 by L, which is a linear differential equation, Let it be my equation 1. So now I solve it. Integrating factor is e to the power integral R by L dt. Okay, is e to the power R by L t. So the solution, the general solution of 1 is given by I is equal to I into e to the power R by L t is equal to integral of E0 by L, or here E by L Q into integration of e to the power R by L t integrating factor dt plus some constant C1. So that is equal to E by L, and integration of this is e to the power R by L t, and this is divided into here L by R plus some constant, I write it C. So now this L and L cancelled, so this is equal to your E by R, e to the power R by L t. Okay, so now bringing this to right hand side, here I is equal to some C, E by R plus C e to the power minus R by L t. Now this is the solution. Now impose the initial condition here. I of 0 is equal to 0. So 2 follows, equation 2 follows, here 0 is equal to E by R plus C. So this implies C is equal to minus E by R. Now you substitute the value of C here. So therefore here I is equal to, here E by R taken common, it is 1 minus e to the power minus R by L t. Okay, so this is the solution we have derived. Now the given data we substitute here. What is your E? Now on substituting E is equal to 100, R is equal to 20 and L is equal to 2, we get I is equal to 200 by 20, 1 minus e to the power minus 20 by 2 t, isn't it? So this is equal to 5 into 1 minus e to the power minus 10 t. Therefore your IT is equal to 5 into 1 minus e to the power minus 10 t ampere. Okay, so this is the general solutions out of this. Now you are given after 2 seconds, okay, after 0.02 second, what I am getting, I of t is equal to, I substituted 5 into 1 minus e to the power minus 10 into 0.02. So this is equal to 5 into 1 minus e to the power minus 0.2. So this is 5 into 1 minus 1 by e to the power 0.2. So this is equal to 0.906 ampere. Okay. So this is your answer. This is your answer. Coming to another question. Now coming to example 2. You have an RL circuit, and here E is, you see, it is not a constant. E is a variable here. 100 sin 150t. So it is a RL circuit, and you proceed in the same way, right? By KVL, right? Voltage drop at R plus voltage drop at L is equal to E is your 100 sin 150t. Okay, so that means I write it L di by dt plus Ri is equal to your 100 sin 150t. And if you simplify it, divide your L, so that means your di by dt plus R by Li is your 100 by L sin 150t. So this implies di by dt R by L, R is 100, L is R is 20, L is 2, 10I is your 50 sin 150t. This is a linear differential equation. Okay, this is a linear differential equation. So your integrating factor is e to the power integral 10 dt is e to the power 10t. So that means I into e to the power 10t is in the right hand side, 50 sin 150t e to the power 10t dt plus c. Here I can use a formula, e to the power 80 sin bt, integration is e to the power 80 by a square plus b square, a sin bt minus b cos bt. So this is the formula of the integration. If you substitute it, we will get, if you simplify it, after using this, you will get I is equal to 5 by 226 sin. So here what is your A? This is your A and this is your B, and 50 is constant. So this is equal to, so that is equal to, you will be getting 50 e to the power 80 10t by 10 square plus 50 square, a sin bt. So 10 sin 150t, a sin bt minus b cos bt, 150 cos 150t plus some constant. Okay, so now bringing this to right hand side and simplifying, we will be getting 5 by 226 sin 150t minus 15 cos 150t plus c e to the power minus 10t. Okay, now we use the initial conditions. I of 0 is equal to 0. So your 0 is equal to 5 by 220, sin 0 is 0 minus 15 into cos 0 is 1 plus here c into e to the power 0 is 1. So if you simplify, your c will be 75 by 226. Substitute c here. Okay, so therefore your I. So now let it be my equation 2. So after substituting, I am getting, this is the answer. Okay, this is the answer. Let it be my equation 3. Again we have, it is asked to find what is q in terms of q. Okay, in terms of qt. Qt means q is equal to here Q is equal to di by dt. If we use it, here Q is equal to integral I dt. Q is equal to here integral I dt. Okay, so you just integrate it. So therefore, what will be your Qt? Your Qt will be 5 by 226. Integration of sine is your minus cos, and 1 by 150 is divided. It is cos 150t, and it is minus 15 by 150. Integration of cos is sine 150t, plus it is minus 15 by 10 e to the power minus 10t. If you simplify, now if you simplify it, it will give you minus 1 by 6780. It is cos 150t plus sine 150t plus e to the power minus 10t. Okay, so now this is my Qt in terms of this. Now coming to the most important things, what is the steady state current? Another thing is that steady state current, what does it mean? Independent of time. Means I can take t tends to infinity. Okay, so for steady state current, here t tends to infinity, then e to the power minus t tends to 0. Okay, now equation 3 will give you, equation 3 gives here, it is this will tends to 0, right, and it will give I is equal to, so equation 3 will give you 5 by 226 sine 150t minus 15 cos 150t. Now similarly equation 4, this is which is the steady state current, Okay, again equation 4 gives, right, in equation 4 this will tends to 0, e to the power minus t tends to 0. So this will give you Q is equal to here, so taking t tends to infinity, this is 0, so it will give you this, which is the steady state charge. Okay, in that way. So we have completed it. Now coming to the final example, which is on RC circuit. Now coming to the solution, here R is 20 ohm, R connected in series with a capacitance, C is 0.01 farad, and E is 40 e to the power minus 3t plus 60 e to the power minus 60, and you are asked to find what is Qt. Okay, you are asked to find what is Qt. So if you draw the RC circuit, you have here R, you have here C, RC circuit, and we have here E, okay, so this is my 20 ohm, this is my 0.01 farad, and this is my E is 40 e to the power minus 3t plus 60 e to the power minus 60. Okay, according to KVL, voltage drop across R plus voltage drop across C is equal to E. So that means Ri plus, it is Ri plus voltage drop at Ri, it is Q by C, 1 by CQ is equal to E. E is here, this is equal to E. Now we want to write it in terms of Q. Okay, so I is dq by dt, so that means here r dq by dt, okay, dq by dt plus 1 by c q is your e, means 40 e to the power minus 3t plus 60 e to the power minus 60. You see, this is a linear differential equation. This is a linear differential equation with this is your p, this is your p, and this is your q. So we find the one more thing we can do, we just subdivide it, then we decide p and q. So that means here dq by dt plus 1 by rcq is equal to 1 by r here 40 e to the power minus 3t plus 60 e to the power minus 60. Now if you substitute all these values of r, c, we will get it dq by dt plus 5q is 2 e to the power minus 3t plus 3 e to the power minus 60. Okay, so now this is a linear differential equation. So what is the integrating factor? Integrating factor is e to the power integral, this is your p, 5 dx dt. Okay, so this is equal to e to the power 5t. Then solution, let it be my equation 2 and let it be the original equation is my 1 here. So now the solution of 2 is given by q into integrating factor e to the power 5t is integration of 2 e to the power minus 3t plus 3 e to the power minus 60 into integrating factor e to the power 5t dt plus c. Okay, so if you simplify it, it will give you integration of 2 e to the power 2t plus 3 e to the power minus t dt plus c. If you integrate it, it is e to the power 2t minus 3 e to the power, it is 3 e to the power minus t and plus c. Now bringing this to this side, so this implies here q is equal to e to the power minus 3t minus 3 e to the power minus 60 plus c e to the power minus 5t. Okay, so now we impose the conditions. Here initial condition is given here, q of 0 is equal to 0. Now coming to the initial condition, q of 0 is equal to 0. What does it mean? T is equal to 0 implies q is equal to 0. So therefore here 0 is equal to, it is 1 minus 3 plus c. So that means c is equal to here 2. So substituting the value of c here, substituting c here qt is equal to here e to the power minus 3t minus 3 e to the power minus 60 plus 2 e to the power minus 5t. So this is the solution. Okay, if suppose if it is asked, find the current, then extra. If it is asked find the current, then here q is equal to integral I dt or I is equal to dq by dt. So you can just you can differentiate it. Okay, so it is equal to dq by dt. So this is equal to minus 1 by 3 to the power minus 3t plus 3 by 6 plus half e to the power minus 60 minus 2 by 5 e to the power minus 5t, if it is asked. But here it is not asked, but if it is asked again, also find it, then you can continue like this. Okay, so with this we conclude. So to conclude, we are given with an RL circuit or we are given with an RC circuit, we find a linear differential equation. Then we know the solution of the linear differential equation, substitute the initial condition and accordingly we move. Now in the upcoming lecture, upcoming application, we will see the RLC circuits. Here we will find the second order linear non-homogeneous or homogeneous equation. Okay, and subsequently we will know the solution technique of this. Okay, now my appeal to you, if this lecture is interesting and helpful, please like and subscribe this channel, which will boost my motivation to upload subsequent lecture for your benefits. At the same time, the new lecture will be displayed to your screen. So thank you all. Have a nice day. Let us close this lecture here.